Hello everyone, this is Teacher Harold, your junior high school mathematics teacher. In this video, I'll discuss week 6 lesson number 1, and this is the circular functions, particularly unit circle. After watching this video, you should be able to define unit circle and find the circular functions of an angle measured in either degrees or in radians. In the previous materials about trigonometry, you were able to define the trigonometric ratios or functions of an acute angle of a right triangle, especially the trigonometric functions of those acute angles that are 30 degrees, 45 degrees, and 60 degrees, or pi over 6, pi over 4, and pi over 3 in radian measures. Also, you were able to evaluate and simplify expressions involving trigonometric functions of these angles. In this video or material, you would be able to extend your skills of finding not just trigonometric functions of those special angles, but also those of angular measures that are multiples of 30, 45, and 60 degrees, or multiples of pi over 6, pi over 4, and pi over 3, including those negative angular measures using the unit circle. We go to the next slide. Let's talk about the circular functions. For any real number denoted by small letter s, we can find the values of the 6 trigonometric functions or circular functions by using the unit circle. A circle with radius 1, so the unit circle can be defined as a circle with radius having 1 unit and whose equation is x squared plus y squared equals 1. Starting at the point whose coordinates are 1, 0, we move s units, or the absolute value of s units, along the circumference of the circle. Counterclockwise if s is greater than 0, and clockwise if x or s is less than 0, meaning negative. We let P of S be the terminal point of arc S. If P of S is the point with coordinates xy on the unit circle, then we define the 6 circular functions that are follows, or 6 circular functions as follows. Now suppose we have a Cartesian plane, so these are the coordinate axes, x-axis and y-axis. And from this figure, we draw a circle whose center is obviously at the origin at 0, 0. Then this circle has a radius of 1, particularly the one that you see right now drawn along the x-axis, the positive x-axis. So this blue segment is the radius of the circle also. And along the arc of the circle, we have 1, 0. So this is the point, the starting point along the unit circle, which is 1, 0 again. And of course, we label the vertical axis as your y-axis, while the horizontal axis is your x-axis. Next. So we simply draw a central angle whose one of its sides is along the positive x-axis. We know that this is the initial side and this one is the terminal side. So obviously, an angle is generated by moving the initial side going to the terminal side. So obviously, in a counterclockwise manner. So upon rotating this initial side going to the terminal side, okay, an arc also is generated, denoted by small letter s. Okay, yan. And since the direction is in the counterclockwise manner, therefore, the value of s is greater than 0 or positive. And if this is your terminal side, at the end of the terminal side, we have the terminal point denoted by capital letter P. Now, because of this terminal point, uh, S is generated, an arc length is generated, which is positive in value. So, P sub S will have a corresponding a pair of coordinates X and Y. So again, the 6 circular functions are as follows. So we have the first one, which is sine of S is equal to Y. Cosine of S is equal to X. Probably your X coordinate is your cosine of S, and while your Y coordinate is the sine of S. Then we have tangent of S, that is equal to the ratio of Y coordinates to the X coordinate. Then, for the remaining 3 circular functions, we have cotangent of S equals X over Y, which is the reciprocal of tangent of S. And followed by secant of S, which is the reciprocal of cosine of S, which is X. So this one right here is 1 over X. And the last circular function is your cosecant S, which is 1 over Y. And this is the reciprocal of sine of S. Next. Now, going back to this figure, we let S be the length of an arc subtended by the central angle theta, which is in standard position on the unit circle. So we have learned that arc length is equal to the product of the radius and the measure of the central angle, usually expressed in radians. Now, since R is equal to 1, then S is equal to 0. So, this is the formula. So, if we declare that R is 1, therefore, S here becomes equal to theta. This means that theta has a radian measure equal to the length of an arc, which is denoted by S. Now, using the definition of the 6 trigonometric functions, we have the following. Okay? Now, for us to define the 6 trigonometric functions, I think we need to use a right triangle here. So, from this unit circle, at point P, we project a segment, a broken segment, perpendicular to this segment, which is along the positive x-axis. And you will notice that there is a triangle formed, particularly a right triangle, because at this point, this segment is perpendicular to this blue segment. And we know that this vertical segment is your y, and this segment right here up to this point is your x. Okay? Yun. Now, and the hypotenuse is what? Equal to 1, since we are talking about a unit circle. A circle having a radius of 1 unit. So this is 1. Okay? Now, using this right triangle, we can now declare the 6 trigonometric functions. So, sine theta is equal to y coordinate over the radius, and that is y over 1, or simply y, which happens to be the equivalent of sine s. And for cosine theta, that is x over r, Since r is 1, so that is equal to x, which happens to be the cosine of s. Then, for the tangent of theta, that is equal to the ratio of y coordinate to x coordinate. And that is your tangent of s. Then, for cotangent of theta, that is the reciprocal of tangent theta. So, that is x over y, or that is cotangent of s. Then, secant theta is equal to r over x, or that is 1 over x since r is 1, or that is your secant of s. And finally, we have the cosecant of theta, that is equal to r over y, or that is 1 over y, which is your cosecant of s. Next. Now, note that the values of trigonometric functions and its corresponding circular functions are the same. Now, in the previous materials, we have only considered the positive angles. These are angles in which the rotation from the initial side to the terminal side of the angle is counterclockwise. Similarly, we have negative angles in which the rotation from the initial side to the terminal side of the angle is clockwise. Taking the two figures, for example, the two images, for example. Okay? Now, we have here angular measures that are all expressed in positive because the rotation that we're considering is from the initial side going to the terminal side, which is counterclockwise. That's the reason for those angular measures to become positive. Okay? Yeah. While on the second figure, you will notice that the angular measures are all negative because the direction of rotation that is being considered here is clockwise from the initial side going to the terminal side in this direction. So this is why each of the following angular measures is negative. Okay? Now, so again, from the first figure, both degree and radians measures are being considered them and they are all positive. Here, ganun din. Okay? Both are degree and radian measures. But the difference of the only difference is compared to the first figure, all measures are negative. Okay. Now, looking at both figures, notice that the terminal point at 30-degree angle is the same as the terminal point at negative 330-degree angle. So, bakit sila parehas? Now, let us try to observe. Now, for the positive 30 degrees, we refer to this illustration. Now, where is 30 degrees? This one right here. Look at the terminal point and the coordinates. So, at this terminal point, the coordinates are negative. The coordinates are square root of 3 over 2 for x and 1/2 for y. Now, what about the negative 330-degree angle? Nasaan yun? Okay, let us locate this one right here. Okay? Now, if we try to observe the two figures, it means the point right here is also this particular point right here. Okay? The only difference is this one right here as an angular measure of 30 degrees, while this one is negative 330 degrees. Now, if you recall about the coterminal angles, it means that these two are coterminal to one another, meaning they share the same terminal side. So, if they have the same terminal side, likewise, they also share the same terminal point. So, if they have the same terminal point, they have also the same pair of coordinates. So this one right here has an x coordinate of square root of 3 over 2, and its y coordinate is the same as 1/2. Okay, yun ang ibig sabihin nun. Or, P of terminal point at pi over 6 is the same as the terminal point at negative 11 pi over 6. So basically, itong nakikita nyo, ito rin yun. Okay? Naka-radian lang. Pero they are equivalent in measure. Okay? This one, these two. Isang value lang yan. Likewise, 30 degrees is the same as pi over 6. Now, which means that these points have the same coordinates on the unit circle. Similarly, if we select other pair of angles from the two unit circles with the same coordinates, we also have what? P of 135 degrees is equal to P of negative 225 degrees. So basically, these two angular measures, which are both in degree measures, are coterminal. So if we say coterminal, they share the same terminal side. And obviously, they share the same terminal point. Okay? Ganun din, 3 pi over 4, P of 3 pi over 4 is the same as P of negative 5 pi over 4. Again, these two angular measures that which are both in terms of radians are coterminal to one another. Same thing with this pair of coterminal angles, parehas din yan. Okay? Next. From the terminal point P of theta of some special angles, referring to the first figure on the left, this one, with labeled coordinates, the value of 6 trigonometric functions varies as we go from first quadrant to the fourth quadrant. Example, so find the value of each of the following. Sine of pi over 2. Letter A, that is 1. Cosine of pi over 2 is 0. Sine of 3 pi over 2 is negative 1. And tangent of pi over 2 is not defined. Example number 2. Find the value of each of the following. Secant of 5 pi over 4 is 1 over x. And what is x? It's negative square root of 2 over 2. Or that is negative square root of 2. Then this one right here, cosine of 5 pi over 4. That is negative square root of 2. Cotangent of 5 pi over 4. We have 1. Of course, 5 pi over 4, the terminal side of that lies in the third quadrant. So it's 1. Then for letter D, tangent of 5 pi over 4 is also 1. Okay? Next. Find the value of each of the following. Okay, cosine of negative 17 pi over 6. Find the angle less than 2 pi coterminal with each of these of the angles involved. Okay. Cosine of negative 17 pi over 6. So if we get its coterminal, we have 7 pi over 6. Therefore, it is also the same as, okay, so nasa quadrant 3 yan. So the given cosine negative 17 pi over 6 is the same as cosine of 7 pi over 6. And that will give you square root of 3 over 2, which is negative. Negative square root of 3 over 2. Then for letter B, okay, therefore, the given trigonometric expression is equal to negative square root of 3 pi over 2. Now, what about letter B? Finding the angle coterminal with negative 16 pi over 3. Okay, we have what? Okay, so you're going to add this by 2 pi 3 times. And you will obtain an equivalent angular measure less than 2 pi. That is 2 pi over 3, which lies in quadrant 2. Therefore, this one, the given in letter B, is the same as sine of 2 pi over 3. Using the unit circle, we have 2 pi over 3 equals square root of 3 over 2. Then, okay. Therefore, the given in letter B is equal to the square root of 3 over 2. Then letter C, finding the angle coterminal with negative 19 pi over 4. So, you add this by 2 pi 3 times and you will get 5 pi over 4. So, saan to? Nasa quadrant 3. Therefore, your tangent of negative 19 pi over 4 is the same as tangent of 5 pi over 4. Using the unit circle, that is equal to 1. Therefore, tangent of negative 19 pi over 4 equals 1. Then, I think this is the last one, letter D. Secant of negative 23 pi over 4. First is, we take the coterminal of this angular measure less than 2 pi. So, add this by 2 pi 3 times. You will get pi over 4, which is in quadrant 1. So, this one right here, secant of negative 23 pi over 4 is equal to secant of pi over 4. Using the unit circle again, we have secant of pi over 4 is 1 over x, and we know that x is 1 over square root of 2. Simplifying this expression, you will get square root of 2. Therefore, secant of negative 23 pi over 4 is equal to square root of 2. Next example, number 4, find the value of each of the following. Okay. Now, this time we are dealing with trigonometric functions of angles that are expressed in degree measures, both negative degree measures and positive degree measures. So, start with letter A. Solution, find the angles less than 360 degrees coterminal with each of these given angles. So, sine of 960, find the angle coterminal with 960. So, that is 960 degrees minus 2 times 360. So, that is 240 degrees. And 240 degrees, its terminal side is in quadrant 3. Therefore, sine of 960 degrees is the same as sine of 240 degrees. Now, using the unit circle, we have what? Sine of 240 degrees is equal to negative square root of 3 over 2. Or that is, therefore, sine of 960 degrees is equal to negative square root of 3 over 2. So, that is your answer in letter A. Now, what about letter B? Cosine of negative 1,485. Okay, finding the angle coterminal with this given angular measure, which is less than 360, that will give you 315 degrees. Therefore, the given angular measure must be added by 360 degrees 5 times. And the result is 315. And this one right here is the coterminal of this negative angular measure. So, yes, it's in quadrant 4. So, cosine of this given angular measure is equal to cosine of 315 degrees. Now, using the unit circle, cosine of 315 degrees is equal to square root of 2 over 2. Therefore, cosine of negative 1485 degrees is square root of 2 over 2. Okay? Next. How about this one? So, cosecant of negative 1110, of course, negative 1110 must be replaced by its coterminal less than 360 degrees. So, you add this by 364 times, so that the result becomes 330 degrees, which is in quadrant 4. Therefore, cosine of negative 1110 degrees is equal to cosecant of 330 degrees. Again, using the unit circle, cosecant of 330 degrees is negative 2. Therefore, cosecant of negative 1110 degrees is equal to negative 2. And for the last item, letter D, tangent of 1935 degrees. Of course, 1935 degrees, you get its coterminal less than 360 degrees. So you must subtract this by 360 degrees 5 times. And you will get the smallest positive angular measure less than 360 degrees, and that is 135 degrees, which is in quadrant 2. Therefore, tangent of 1935 degrees is equal to tangent of 135 degrees. Using the unit circle, we have negative 1. Okay. Therefore, tangent of 1935 degrees is equal to negative 1. Okay? And that ends our discussion about circular functions of using the unit circle. See you next time.